Welcome to Pharma Drama, the channel where we look at the science of healthcare and healthcare products. In this video, we're going to look at one of the methods of drying most commonly used on a commercial scale, fluidized bed drying, which funny enough doesn't involve fluids or beds. It is, however, the best method of drying wet solids quickly and cheaply and on a large scale, so it's good to know how it works. So don't let yourself dry out. What have I got? Coffee. And let's make a start. Most pharmaceutical products are tablets and capsules and are manufactured on a large scale. If you look at the box of a typical medicine, you will see there are usually between 10 and 20 ingredients listed, and these must be uniformly blended during production to ensure each dosage form is identical. Mixing is usually achieved with a process called wet granulation. The powders to be blended are added together with some water. The water helps soften and dissolve the powders, helping them to blend together into large granules. While being soft also helps with mixing, it means the granules are difficult to process because they don't flow well, and so they must be dried. Removing the water turns the granules back to powder, and powders flow much better. This means that during pharmaceutical production, there is usually a need to dry large masses of wet granulated material. Also, when raw materials are delivered to a factory, they may have too much water to flow properly, and so must be dried prior to the start of manufacturing. All of this means that there is a need for a method that can dry large masses of wet solids quickly and efficiently, and the method of choice is fluidized bed drying. Fluidized bed dryers can be scaled to handle almost any commercial amount of material, and are very efficient in terms of drying time and energy cost because they achieve drying of particles in just a few seconds, and they can be found in almost all pharmaceutical production facilities. How then do they work? I know you're desperate to know. This diagram will help me explain. The material to be dried is placed in the drying chamber, and hot, dry air is pumped in underneath the wet solid. Initially, the weight of the solid is great enough that the hot air cannot move it, and so there is a build-up of air pressure at the base of the dryer. As the pressure builds, however, the powder will start to rise, and eventually the air pressure will be great enough that the bed breaks apart into individual particles, each of which is aerosolized in the hot air. At this point, the bed is said to be fluidized because the particles are able to move freely about inside the dryer in the hot air. This is where the name fluidized bed drying comes from. Because the bed is fluidized, the surface area of the particles in contact with the hot air is huge, and this leads to very fast evaporative drying. This is in fact why fluidized bed drying is so cost effective. The drying time of individual particles can be as short as a few seconds. An additional benefit of fluidized bed drying is that while the particles are freely moving around in the air, they are able to bounce off each other, and this has the effect of knocking any rough edges from the particles, smoothing their surfaces. This leads to better flow properties of the dry powder. Now, you might say to me, why doesn't the wet solid just get blown all over the laboratory with all that hot air? And I would say, that's a good point. No one wants their sample stuck to the ceiling. So in order to ensure the sample stays in the dryer, there is a filter above the fluidized bed that keeps the particles from escaping, but which also lets the air out. If the air couldn't escape, the dryer would continue to pressurize, and we would be creating a potential bomb, and we don't want that either. There is one big risk of fluidized bed drying, however, and that is a dust explosion. When the powder particles are being smashed together and smoothed, there is a risk of creating some very fine particles. Fine particles have a huge surface area, and because most pharmaceutical materials are organic compounds, they tend to be flammable. When you have flammable particles in an oxygen-rich environment, you have 2 of the 3 things needed for an explosion. The only thing missing is a spark. So you need to be careful when using fluidized bed drying to ensure no dust can escape into the local environment, and also that there are no spark sources. Here are some pictures of some fluidized bed dryers. You can see they can be very small or very large, and they're used in all sorts of industries. Right, that's all we need to know about fluidized bed drying. Hot air is passed through a bed of wet solid, lifting it up and separating it into individual particles. At this point, the bed is said to be fluidized. Drying is rapid, on the order of a few seconds per particle, and because particles are bumping into each other, we end up with a smooth, free-flowing powder. The main risk of fluidized bed drying is a dust explosion, so the environment in which the dryer operates must be tightly controlled, and in particular, there needs to be no ignition sources or sparks. If that helped, please hit the like button and consider subscribing. It really helps the channel. Otherwise, thank you so much for watching, and I'll see you again soon.